So about me, I use he, him pronouns, and I go by Mickey, even though my name is Mikuláš. So I've been born in the Czech Republic, so it's a nice homecoming having EuroPython here. I'm going to be sad when it leaves, but I actually live in London, in the United Kingdom. I did my master's there and work there. I've been coding in Python for more years than not, but more importantly, I've been using Django for about 11 years, and about 10 of them I've been using this technology that I'm going to be talking about. I'm a staff engineer at a company called Zelix. We're a SaaS company in London. If you're looking for a job, come talk to me afterwards. If you're interested in the slides, you can scan this QR code. I'm going to also post the links afterwards. And yeah, you can also find the slides on my website. And if you need to get in touch, you can do that here on the links. So just a little overview of what we're going to talk about. We're going to go over what actually SaaS is and what the problem is a little bit. We're going to build a little demo application that is going to highlight the problems. I'm going to introduce you to Postgres schemas and the library that we're going to use to manage these schemas in Django, called django-tenants. A little bit how we use it at Zelix, and then what the trade-offs are with the solution that we're going to introduce here. And there's some very soft prerequisites, and that's Django and SQL. So I'm going to use a little bit of SQL in the talk, but hopefully it should be self-explanatory. And if you know a little bit about Django, it's probably going to help you understanding. So what even is SaaS? So software as a service is a method of providing software, right? And it's provided in the cloud managed by the seller. And this is oftentimes a web application, right? So the customer accesses this software by just accessing a website. So, Django obviously comes in mind. And this is very much in contrast to an on-premise model where you build an app, you package it somehow, you ship it to somebody else's computer, and they install it and run it from their own computer. And tenants in SaaS, in a software as a service environment, is a very common concept. And it's essentially that each customer is a tenant of this application. And importantly, all of these tenants share their infrastructure, right? So we build one web application, and multiple different tenants, so multiple different customers, access this one application. So we're going to build a very simple SaaS app just to highlight some of these issues. We want to sell to multiple companies, so that's the core requirement. And we want to find duplicates between invoices that the customer has to their vendors or suppliers. We want to show the invoices, and we want to show the suppliers as well to the individual users, and need to be fast, secure, and reliable. Those are like very basic requirements. And probably it's not going to be surprising about Zelix itself. I promise I'm not trying to sell you Zelix. I kind of doubt that you're working in accounts payable at a large corporation. If you do, come talk to me, and we can work something out. But I'm actually just highlighting how we use it and how it can help you build your applications as well. So this very basic application, we have a tenant model. This is the list of our users. Obviously, we've got users. So we've got a foreign key to the tenant. So we obviously know which user belongs to which customer. And then we've got the supplier model. A supplier model just has some name, but it's most importantly linked to a specific tenant, because we want to show just specific suppliers to a specific tenant. And then we get to invoices. We've got an invoice model that's actually linked to the supplier, and through a foreign key there we have access to the tenant, so we know which tenant an invoice belongs to. And finally, we've got the two duplicate invoices, right? So if you want to, for a current user, show the data for that specific tenant, you have to query for it. And in Django, you get the current user from request. You get the tenant from the user, because we've got the foreign key, and you just filter like this, right? For invoices, it becomes a little bit more complicated, because we first have to join to the supplier to get the tenant, and then we can filter on it. And for invoices, it becomes even more complicated, because we have to filter for both of the invoices, supplier and tenant. In theory, depending on how much you trust your code, you could probably just do one of the filters, but you need to really make sure that you only ever insert data that belongs to the same tenant, right, to the model. So it's a bit safer to do this that way. The summary essentially is every single database query for the tenant data, for the customer's data, needs some filtering on it. And that's one of the first issues that we have with it. You need to remember every single time to do that filtering. Otherwise, you're going to have a massive problem. There's a really cool package called django-scopes that makes this much, much, much easier. It basically throws an error if you don't do the filtering, but you still have to do the filtering. So it's a bit annoying. And when you're writing tests, you need to cover every single scenario. So you need to write at least one test that is not showing somebody else's data. You need to cover all of the cases. And most importantly, if you forget to do this filter, it has pretty bad consequences. Big companies are usually very sensitive about their data, and therefore, if you show your data, somebody's data, to somebody who doesn't have access to it, that can lead to lawsuits. You can probably go bankrupt, to be honest. On top of that, filtering through these, doing these filtering, and especially when you're doing the joins, is pretty expensive. So every single select query has a cost associated with it. You have to, look up in an index, and even though it's an index, it still has some cost associated with the lookup. And insert queries are also a bit slower because the bigger the table grows, when you've got a lot of different customers, you have to update a bigger table and update a much bigger index. So the more customers you have, the worse it becomes for everyone, because the tables are getting bigger, right? So you can help a little bit with denormalization, like every database teacher in university is screaming right now, like, do not denormalize your data in relation to database, but in practice, it does help. So for example, in the duplicate invoice model that I had before, if we add the tenant as a foreign key to it, you can then filter directly on it, and instead you don't have to do 2 joins on invoice and the supplier. So it's a bit of a denormalization help, but it comes at a cost as well. And that's the database size, right? The tables and indexes grow in size more quickly when you've got these foreign keys in there. When you have to have, on every single table, you have to have a foreign key to something that's saying which organization it belongs to. And that's especially the case if you have a denormalized table, like I showed before. And the large tables that you have in your application affect all of the customers equally. So if you've got a really small customer and a really big customer, they both have to query a really big table and use the same really big index to filter on that data. I have a little bit of an example about denormalization. So I just created a very basic database table with about half a billion rows. So, and adding a tenant column to denormalize it adds about 3.4 gigabytes of data and 2.8 gigabytes of indexes. So, it's not a crazy amount of data, but it adds up when you have a lot of different tables. And then we finally get to Postgres schemas. So Postgres is a SQL database. I hope everybody knows at least a little bit. And schemas refers to its namespacing solution. And as the Zen of Python says, namespaces are one honking great idea. Let's do more of those. So the schemas are is a namespace within the database. And everybody who uses Postgres by default already uses schemas, because everything by default belongs to the public schema. But each of the database in your database server can have multiple different schemas in it. And each of the schema has its own tables, indexes, and data. And you sort of can see where I'm going with this. We'll separate it into each tenant into its separate schema. Finally, the tables can actually refer to other schemas. So for example, you can have a foreign key to a user, which is in the public schema, in a tenanted schema. We'll get to that in a little bit. I'll show you a little bit in SQL how to use it. So creating a schema is pretty simple. You just say create schema. It's just like English. And when you're creating tables, you just specify the schema that you want to create the table in by just having this prefix like tenant.supplier, supplier, right? When we want to select from a specific schema, you also just add the schema name, and then it just works. It returns data from a specific tenant. That gets a little old, so you can actually just set the namespace for the remaining queries in your connection. So if you set the search path to tenant, it basically says, unless I specify the schema exactly, just return data from the tenant1 schema. But you can still actually, in the same connection, you can still refer to a different schema in there. And finally, you can actually have multiple different parameters to the search path, where it's like a primary schema and a secondary schema. So in this little example, I didn't show this in the Django model, but if we have a on-supplier, if it's a tenanted application and we've got it in the tenant1 schema, we can actually have a foreign key to a table that's in the public schema. So in this little example here, this would work just fine because the user lives in the public schema, it's in the secondary. So the way to use this in Django, it's this library called django-tenants. And a full disclaimer, I did not write this library, and I don't maintain it. It's maintained by a guy called Tom Turner with the help of Alexander Todorov. And it's actually a fork of an even earlier library, Django-tenant schemas by Bernardo Pires. But I've been using both of these about a decade. So I've been using Django-tenants for 5 years. And before that, I used Django-tenants for 4 years before that. So I've had quite a lot of experience with it, so I feel like I can speak about this and explain to you how to use it. And how it works, it splits your Django applications into shared and tenanted applications. So the shared applications live in the public schema, and they're shared between all of the individual tenants. So we could have the user there, we could have the list of organizations there. And the tenanted apps are live in a schema for that dedicated, for that specific tenant for you. And the library routes the request to the correct schema based on the subdomain that's available in the request. So this addresses some of our issues that I highlighted before, right? Once you set the tenant, you then don't really have to think about setting the tenant again. All of the SQL queries will be routed to the correct schema. You don't need to filter everywhere, right? Because we don't even need to have a foreign key anymore in the database table to the tenant because it belongs to the one schema. And the queries are a lot faster without the filters. So the same database data that I generated before when I had about 460 million rows, when I queried for all of the invoices for a specific tenant with 50 million invoices, which is about the size that we have at our company, sometimes it takes about 26 seconds. And that actually just has one extra column. And if you query a table that doesn't have any foreign keys, it's just the 50 million rows, and you select all of them, it takes 4 seconds. So it's much, much, much faster when you don't have to do the filtering on it. And the indexes and tables don't grow as quickly because the data is separated by the tenant. So when there's a small tenant and a big tenant, obviously the big tenant might be a little bit slower, it's got a bigger table, but the small tenant will be quite fast because it's got a smaller table. Additionally, this all leads to having like the performance issues localized to tenants. Like I said, the small tenant only has small tables, so the indexes are quite a bit smaller, it's faster. On top of that, you've got full segregation, data segregation, right? And companies often want to have this like as part of your solution where there's no risk of leaking data from one customer to a different customer. It's easy to export or delete a specific tenant because it's all localized to one schema. You don't have to go through 300 tables with a cascade delete. You just drop the entire schema and you're kind of done. And it's easy to export, so Postgres allows you to export the data of just one specific tenant, for example, or one specific schema. So when you have to play with some data locally, it's much easier to get just part of your database instead of the entire database. And when you're running migrations, it actually allows you to have like shorter locks on the tables. So when you are running migrations, when you're adding a new column, for example, to a database table, it requires a exclusive lock on that table for a little bit to actually be able to add it. And by just having smaller tables, it's much faster to do this, right? You've got multiple little small ones instead of one really big one. The Django-tenants library for you manages the lifecycle of the schema, so creating and deleting. It runs the migrations for all these schemas. Because we've got tables in multiple different schemas, we have to run the migration in each of these schemas individually. It obviously routes the request to correct tenant based on the subdomain. And it also allows you to do, for example, tenant-aware file handling. So you've got static that's very specific to a tenant, or the media, like the user uploaded content, is also, is namespaced by the tenant. And it does a lot more, so you could check out the documentation. I'm going to go through how to install it a little bit, how to set it up. It's not very hard. It's also an oversimplification. You should check out the documentation for it. So the first step you need to do is update database settings. You create a tenant model. You then configure which of the apps are shared and which are tenanted, and add some middleware. And that's basically it. So in the database settings, you actually just need to change the engine of your database and add a database router. The database router makes sure that the migrations run in the correct schema. We already have a tenant model, but we need to add a domain model. So that's how Django tenants know which domain links to which tenant. And we just need to use tenant mixin and domain mixin from the library. And after you do that, you need to configure it in the settings to set the tenant model and the domain model. To define how to share which apps are shared and which are tenanted, you use these two new settings, shared apps and tenant apps. And you can see that in shared apps, we've got the list of tenants and list of users is shared, and the supplier invoices and tenanted apps. I really like separating in your structure of the repository. I really like separating which of the apps are public and which are the tenanted, so you can see immediately which are which. So I've got this little public and tenant in there. And finally, you just combine it in the installed apps. The middleware is just called tenant main middleware. There's like 2 different ways you can route requests. So this is the main one. And what it does, it's not very complicated. It just retrieves the domain from the request. It looks up the domain instance for that specific domain and activates the linked tenant. So I've got a little snippet of how it looks. So the 3 ellipses is how you actually look up the domain from the tenant from the domain. And then you just set it on the connection, the database connection .set tenant. And you basically, for the rest of the requests, all of the database queries are linked to the correct schema. To query the data across, from the current user, it's pretty simple because you can just do .all, and .all. So suddenly it becomes much simpler to actually select your data, and you don't have to do any filtering anymore. So about how we use it at Zelix, we've been using it for about 5 years, so I think we've got quite a lot of experience with it at this moment. So Django-tenants supports alternative methods of routing. And the default routing is by domain or subdomain. It also supports by a URL path, so you've got a domain / something / the schema name, or like the tenant name. But it's easy to hack or implement other methods, and that's actually what we've done. We've got a custom routing. We don't use the main middleware, we use our own middleware, which sets the tenant based on the user. So that leads to not having multiple different subdomains that we have to support. The user just goes to our domain.com or whatever, and based on which user logs in, we activate the schema. What it also leads to is, if we're a staff user, we can select which customer's data we take a look at. So it looks a little bit like this. If the user is a staff user, we somehow select the tenant from some session storage. Like we can select which organization we want to do. If it's not a staff user, we activate the tenant of the user that's currently logged in. The rest looks exactly the same. So in our main deployment, we've got about 130 tenants, where 80 tables are in the public schema and 300 tables in each 10 schemas. And for the number of objects, we've got roughly millions of suppliers, hundreds of millions of invoices, millions of duplicate invoices, and then 1.5 billion or probably 1.6 billion by today or something like that in another table relating to the invoices. So that's like the sum of all of the tables in all of the schemas, obviously. And at that scale, it really becomes quite expensive filtering by a specific index, right? When you need to select 500 million rows for some request. But obviously, this all leads to new and exciting problems. We're tired of the old problems that we have, but suddenly we have new problems. So, and the first one that you have is, I mentioned this before, you need to run migrations on all of the tenants that you have and the public schema. So this is obviously slower. You have to run the same migration again and again. And if your migration fails, for example, if you add a constraint that's, for example, not valid in one of the schemas, it fails. And then you got inconsistent database state between individual schemas. And that's something you have to handle, and obviously the way to do is to only ever deploy perfect migrations that never fail. But we all live in the real world, and sometimes it just doesn't happen. Django-tenants can run these migrations in parallel, so you can be running migrations on 4 different schemas at the same time. Obviously, that's a trade-off between how much you are hitting the database, how much wall time it costs. But at Zelix, we've actually developed a smarter executor of these migrations, which we actually open sourced as well. So that's a Python package that you can install and start using. I open sourced this a couple of weeks ago, where it's a little bit more optimal with how it runs when there's no migrations to be run. So it speeds up the migration quite a bit. And another problem that you have when you implement this is cross-tenant analysis. So obviously you want the data for the individual customers to be segregated so you don't return the wrong data to somebody else, but sometimes you just need to actually analyze something that you've got in there. So for example, just to count all of the individual invoices that you got in all of the tables, you can't run a simple SQL query that just gets you that. You have to think about it a little bit more and actually implement it a different way than you would do. Like you cannot just run duplicate invoice.objects.count because you've got the same table in so many different schemas. So there is a way you can create an SQL view which unifies the data across all of the tenants. It's a bit of a hack, but it works. But under the hood, it actually still runs the query every single time as well. But the way we usually do it is actually run a query in each tenant and join the results. So Django tenants allows you to activate the specific schema for a block of code with this with operator, obviously. So you just run the query again and again for each specific tenant, and then you join the results. Harder becomes a little bit hard. Testing becomes a little bit harder. Sorry about that. So you always need a tenant in your applications in the tests to actually, see what gets returned. And to have a tenant in your test, you actually need to run the migrations on it as well. This slows down all of the tests. So if you've got quite a bit of tables as we have, just creating all of them from scratch takes 2 or 3 minutes. And when you're testing applications, you don't want the test to take 3 minutes. You have to be a little bit smarter about that. So this is a bit of a concern. So at Zelix, we use PyTest for testing, and in there we use session-scoped fixtures for the tenants in test. So when you once run the migrations at the start of the entire testing session, it doesn't have to run them again and again for every individual test. That helps a lot. But on CI, we go a little bit further than that. We run the migrations in one tenant, and then we replicate the schema to other tenants that we have in the database. So for our test, we sometimes need to, for example, test the cross-tenant analysis. We need to have multiple different organizations in the test so we can run that it actually does something correctly. And to speed up the runtime, we actually just run the migrations once and then replicate the schema. It's also pretty hard to migrate to Django tenants. It's a very different design to your database, so doing it without downtime becomes almost impossible, I think, to be honest. I think it's doable with downtime, but you probably need to write some really custom management command or custom SQL to actually separate the data, because you need to essentially have one table and then gradually migrate the table into individual smaller tables in each schema. When I implemented this 5 years ago, it took me about 3 weeks or 4 weeks to implement, and we had an afternoon of a downtime, but that was before we added probably 400,000 lines of code. So it's better to do it at the start of the project or very early on. And so to conclude, building SaaS is hard. You always will have some issues. With Django tenants, you can help with several aspects, but it's a trade-off like everything else. You will introduce new issues at the end. And that's it. And this is the link to the slides. And if you've got questions, we can go questions now. Thank you.
Who have questions?
Hi. Thanks, Mickey, for the talk. I'm Alan. And we actually use Django tenant schemas where I work.
Okay.
Really nice talk. Thank you for explaining all of that. I was interested in the project, so it was before my time.
Yeah.
What would you say are the differences between that library and Django tenants? Are they noticeable?
So it's not a big difference because Django tenants is obviously a fork of the earlier library. So one of the main differences at the start is in Django tenant schemas, the domain is a property of the domain of the tenant, right? So you basically have one domain per tenant, while Django tenants allows you to have multiple different tenants, multiple different domains pointing to the same tenant. The other reason, the other function, it also has active development. I think Django tenant schemas has stopped being supported for a couple of years ago, and Django tenants still has active development. It also has a reasonable community support. There's packages that allow you to make it better. So for example, iLibrary, there's Django tenants users, there's other different libraries that use it. And they also have the alternative methods of routing to the tenant. So you can have the routing where it's actually in the request, where it's /r/name of the tenant. I don't think the Django tenant schemas has that. So it has multiple different ways of routing to the tenant rather than just the domain one as well. Yeah. But otherwise, under the hood, it's all the same library actually, because it's a fork, right? So I think it's mostly compatible. I think you wouldn't find it too hard to migrate to it if you really wanted to.
Yeah, thank you. I was also thinking about it. And I have other questions, but those are the hard bits that you talked about.
Yeah, of course. Yeah, just come talk to me afterwards and we can have a chat, of course.
Thank you.
No worries.
Anybody else?
Thanks for the presentation. Do you work in an async manner
with the Django tenant?
So we haven't really done that yet. I know it's a bit more complicated because the connections need to be alive for longer. I haven't worked with it, so I don't know if it actually works. But I know I can probably see some issues already. So one of the things is to activate. So like I was showing how you activate the schema for a specific connection, right? So by default, Django tenants does it before every single query, but that actually makes it that every single query has it becomes two queries. So like you have introduced a little bit of latency for every single query. What we do, there's a setting where you just set it for the entire connection and all of the other ones. I can see that being an issue with async. I don't know if you've experienced that.
No. I was looking at the middleware and I was wondering the same. But and another question, when you have a new client, do you have to do like manual work, or is it everything is dynamic?
No, so it's not very manual. So Django tenants handles the creation of the schema and the initial migration for you. So when you create it, you can modify the behavior a little bit, whether it's automatic or whether you do it yourself. But by default, when you create a new instance of tenant, you do .create, whatever, it creates the schema and runs the migrations immediately. For us, that's a little bit annoying because migrations on a schema run for like 2 or 3 minutes. So actually, that's too long to do within a single request. So what we do, we just create the row in the tenant table and run a salary task in the background, which actually runs the migrations. So for the user, they're just not allowed to impersonate, like go to it immediately. It takes like a couple of minutes for it to spin up. You can modify the behavior a little bit, but you don't have to do much manual work. Like by default, it just does it for you.
Okay, thank you very much.
Hey, nice talk. Do you guys operate on one market or many countries in Europe?
Yeah.
So every country invoice looks a little bit different.
Yeah, it's a bit of a problem. So like that's more specific to our business. I'm happy to talk about it. I'll give a little bit of a summary. So we connect to ERP systems, so like think about a SAP, right? And the SAP has standard interfaces. So whatever country you're on, it has the same invoice fields essentially. So we're pretty easy to pull out data from multiple different countries. But we can talk about that a little bit more specifically.
But does this library somehow help to configure the fields
So you might know about Rossum. There was the keynote 2 days ago. So they're more focused on the pulling out of the data from the invoice itself. We actually already just load the data that was already loaded into a SAP, for example. So we already have the data in a standardized manner, so we don't have to deal with unstructured data.
Okay, thanks.
You said you ran salary job to create the schema. And,
yeah.
My immediate thought was triggers, database, PostgreSQL triggers. Have you considered that? So, in case others don't know, PostgreSQL has this ability to do something when something happens.
Yes,
trigger.
yeah,
So
for sure.
the new row in the tenants table could trigger creation of the schema on the database level.
Yes, you could definitely do that. But then, so for the schemas, it'd be pretty easy. But for migrations, it's less trivial because you won't actually want to run Django migrations, right? So you basically need to run Python code. So I don't know if Postgres can call generic Python code. Maybe if yes, I probably wouldn't recommend it. So like for us, it's easier to just run a salary task to do that for us.
Thanks.
I think there was a question there in the back.
Probably last one.
Yes.
We have 2 minutes.
Thank you for the talk. If you had to give advice to somebody starting a new project, would you recommend they go with Django tenants always? Would you recommend something like Django scopes? In some cases, what would be your criteria to make the decision?
I think for me, it would be like, what's the expected future of the project? So I haven't really gone into this, but if you have thousands and thousands of customers, it might become a problem to actually run the migrations. So we're a B2B company where we've got dozens, hundreds of customers at most. Well, hopefully we'll scale to infinite growth, but for now we only got about 150 customers or something like that. So that's a manageable scale where you don't have to run the migrations. But like I know there's been discussion even on the GitHub repo where people have multiple thousands of tenants and then the migrations become a real issue. The management of it becomes quite a bit of a pain. So it's a bit of a trade-off in this regard. I think it probably most depends on what your expected future for the project is, and whether how much is it to B2B or is it B2C, and that sort of things, like how big of the data like you expect. So we knew from this, like when we implemented this, we knew that the number of invoices and other data that we have in our database will grow quite quickly. If you don't have that much data, you are probably fine with indexes. It's a bit of a trade-off game, really, in the end. Yeah. Okay.
Okay. Thank you, Mikuláš.
Yeah. Thank you very much.